Hello everyone, we are Group 4A. Our topic is how are changes in microbiota related to the onset of cancer? Since the microbiota in the human body mainly refers to the gut microbiota. Today's talk will examine how changes in microbiota are related to the onset of cancer. We will also talk about how gut microbiota balance affects cancer in three ways. The first is the immune system, the second is metabolites, and the last is inflammation. First, let me tell you a little about the gut microbiota and its importance to us. The human gut microbiota refers to the trillions of microbes, such as bacteria, that live in the human gut. Most microbiota in the body are useful, but they may become harmful when out of balance. The gut microbiota is a vast and complex collection of microorganisms that profoundly affects human health. Previously, people referred to the gut microbiota as the microflora of the gut. The gut microbiota assists in a range of bodily functions, including harvesting energy from digested food, protecting against pathogens, regulating immune function, and strengthening biochemical barriers of the gut and intestine. Changes in microbiota composition can affect these functions.
This part is about the impact of immune system on cancer. Gut microbiota impacts cancer by modulating immune responses, enhancing anti-tumor immunity, which can affect tumor development and treatment efficacy. There are effects on three major aspects of the immune system. The first one is influence on regulatory T cells. The second one is antigen presentation, and the third one is microbiome and cancer therapy. Influence on regulatory T cells. A balanced microbiome fosters the development of regulatory T cells, which play a crucial role in maintaining immune tolerance and preventing autoimmune responses. An adequate population of TRACs can help suppress excessive inflammation and promote a healthy immune environment, reducing the likelihood of cancer development. The second aspect is antigen presentation. Antigen presentation. The gut's microbiome can enhance the ability of antigen-presenting cells to recognize and respond to cancer cells. A diverse microbial community supports effective antigen presentation, leading to a robust immune response against tumors. The third aspect is microbiome and cancer therapy. The gut microbiome may also influence the efficacy of cancer treatments, such as immunotherapy. A diverse and balanced microbiome can enhance the response to these therapies by modulating immune pathways, suggesting that microbiome health could be a critical factor in cancer treatment outcomes. The first two aspects is about enhancing the immune response. The third aspect is about improving the efficacy. The immune response is the body's defense mechanism against pathogens, involving recognition of foreign substances, activation of immune cells, and production of antibodies to eliminate threats and maintain homeostasis. Immunotherapy is a cancer treatment that harnesses the body's immune system to recognize and attack cancer cells, enhancing immune responses through various methods like checkpoint inhibitors and CAR T-cell therapy. In conclusion, gut microbiota significantly affects the tumor immune microenvironment by regulating the functions and interactions of various immune cells, thus shaping the body's immune response to cancer and affecting the therapeutic effect. These findings provide new ideas for enhancing the efficacy of immune checkpoint inhibitors by regulating the gut microbiota.
Now let's focus on the impact of metabolites on cancer. The gut microbiota has strong and diverse metabolic abilities, and they continuously undergo various biochemical reactions in the unique ecological environment of the intestine, producing a wide variety of the metabolites that are closely related to our physiological functions and health status. Let's first talk about the mechanism of the metabolite production. The gut microbiota can use endogenous substances in the intestine and a variety of nutrients consumed in our daily diet as substrates for metabolic processes. For instance, they can go through metabolic processes that the human body hasn't yet digested and absorbed, like fermentation and the transformation of dietary fiber, protein, carbohydrates, and so on. And here's some common metabolite types. The first one is short-chain fatty acids. It mainly includes acetic acid, propionic acid, butyric acid, and about vitamin. When the intake of vitamins in the human diet is insufficient, the vitamins synthesized by gut microbiota can be supplemented to a certain extent to maintain normal physiological functions of the body. And the third one is bile acid derivatives. Bile acids are synthesized by the liver and secreted into the intestine, helping to digest the fat and participating in maintaining immune balance in the intestine. And there's also some other metabolites like hydrogen, methane, carbon dioxide, indole, and its derivatives. And here's the balanced gut microbiota and the beneficial metabolites. Let's mainly talk about the short-chain fatty acids. The short-chain fatty acids are mainly produced by anaerobic bacteria in the intestine through fermentation. Among them, the genus Bifidobacterium plays an important role in fermenting dietary fiber to produce acetic acid. And dietary fiber is one of the most important substrates for producing short-chain fatty acids. This contains both water-soluble dietary fiber and water-insoluble dietary fiber. So there's the anti-cancer properties of the short-chain fatty acids. First, it can induce apoptosis of cancer cells. At the level of cancer cells, the short-chain fatty acids such as butyric acid can affect the apoptosis-related signaling pathways within cancer cells. And secondly, it can also inhibit cancer cell proliferation by affecting the cell cycle regulation of cancer cells. So finally, the short-chain fatty acids can interfere with the abnormal metabolic patterns of cancer cells, limit the pathways through which cancer cells obtain energy, and make it difficult for cancer cells to maintain malignant behaviors, such as rapid proliferation in the absence of the energy supply, ultimately achieving anti-cancer effects. Besides the benefits, let's talk about the imbalance of the intestinal bacteria and the carcinogenic compounds. So under the normal circumstances, types and the quantities of the various microorganisms in the gut microbiota are in a relative stable proportional relationship. However, when influenced by various external or internal factors, this balance can be disrupted, resulting in an imbalance of gut microbiota, also known as ecological imbalance. In addition, unhealthy dietary habits, such as long-term high sugar, high fat, and low dietary fiber diets, can damage the environment in the intestines that is suitable for the growth of beneficial bacteria, and harmful bacteria that prefer these unhealthy foods will breed in large numbers. And at last, I like to say something about the production and types of the carcinogenic compounds. The first one is nitrothermic compounds. Nitrothamides can undergo alkylation reactions with genetic material such as DNA inside cells, causing changes in DNA base pairs and triggering gene mutations, thereby initiating the process of the circular carcinogenesis. And the second one is secondary bile acids. When the bacteria are imbalanced, the production and types of secondary bile acids may undergo abnormal changes. Certain specific secondary bile acids have cytotoxicity, which can damage the DNA of the intestinal epithelial cells and activate some carcinogenic signaling pathways in the intestine, increasing the risk of cancer. So the last one is polycyclic aromatic hydrocarbons. Some bacteria in the gut can be metabolically activated in an imbalanced state, transforming them into more carcinogenic forms. They can interfere with the normal metabolism, proliferation, and differentiation processes of cells, and are associated with the occurrence of various cancers.
Hello professors, it's my part to introduce the impacts of inflammation on cancer. Okay, let's begin. There are 4 mini parts I need to talk about so which you can learn about the impact of inflammation, cancer, and something about microbiota. The first mini part is dysbiosis of gut microbiota can induce activation of intestinal inflammations, leading to sustained inflammatory response, immunopathology, and tissue damage, and in severe cases may lead to the occurrence of tumors. The gut microbiota can activate the inflammatory response in the human body, increase the secretion of pro-inflammatory cells and cytokines, trigger oxidative stress, alter energy dynamic, damage DNA, and ultimately promote tumor growth. Mendelian randomization analyses showed a significant causal relationship between decreased level of inflammatory and protein factors AXIN1, beta, NGF, and PD-L1, and the reduced risk of rectal cancer. The expression levels of these factors are correlated with the TNM staging and tumor differentiation degrees of rectal cancer, and may be new targets for the treatment and the prevention of rectal cancer. Chronic inflammation is an important factor in the occurrence of digestive system tumor. The chronic and the non-inflammatory states mediated by gut microbiota imbalance is prone to stimulate tumor formation, mainly related to immune cells and the cytokines they produce. The immune cells in these microenvironments and the cytokines and the growth factors they produce activate related to signaling pathways, causing the expression of chemokines, inflammatory factors, and antimicrobial peptides, promoting tumor cells proliferation, inhibiting tumor cells apoptosis and anti-tumor immune response, promoting tumor cell invasion and metastasis, tumor angiogenesis, and other malignant mycologic behaviors. There is a close relationship between inflammation in intestinal cells population and cancer. Inflammation is not only an important factor in the occurrence of cancer, but also plays a crucial role in its development and progression. By regulating gut microbiota and controlling inflammatory responses, new strategies may be provided for the prevention and treatment of cancer.
Next, I will talk about what we can do to prevent cancer. First, from the immune system's perspective, a healthy gut microbiota enhances the immune system's ability to identify and eliminate cancer cells. At the same time, an imbalance may allow cancer cells to escape immune surveillance. To prevent cancer, we can consume foods rich in prebiotics and probiotics to promote the growth of beneficial gut microbiota. Second, from the perspective of metabolites, a healthy gut microbiota produces anti-inflammatory and anti-cancer metabolites, whereas an imbalance may lead to harmful substances. So, we can include foods rich in dietary fiber to encourage the production of beneficial metabolites and reduce cancer risk. Also, we should minimize consumption of high fat, high sugar, and overly processed food, which can disrupt gut microbiota balance and produce harmful metabolites. Third, from the perspective of chronic inflammation, an imbalanced gut microbiota can trigger chronic inflammation, creating a favorable environment for cancer development, particularly colorectal cancer. Therefore, we should reduce the level of inflammation through moderate training and promote the diversity of intestinal flora. Use antibiotics with caution, as they can disrupt the balance of gut microbiota. Improve sleep quality. Good sleep can help restore the balance of gut microbes and reduce the risk of chronic inflammation. So, this is how our changes in microbiota related to the onset of cancer. Here are our references. Thank you.